In this example, we have 3 columns of data. The first column, column A, is simply an ID number for each of 15 Canadians in a random sample that has been drawn from the Canadian population. The second column, column B, gives the number of hours that each of those 15 Canadians told us that he or she had spent watching television in the last week. So I respondent number 1 here said it was 15 hours last week, number 2 said it was 7 hours last week, and so on. Column C is full of 28s. Column C just represents the average number of hours that we know Americans tend to spend watching TV in a given week. What we're going to have Excel do here is, first of all, average all of these values to come up with the average number of hours that our 15 Canadians said that they had spent watching television last week, and compare that to what we know to be the average among all Americans to see whether there's a difference. And then if there is a difference, which there is, we're going to see whether that difference is large enough to suggest that there's a similar difference between all Canadians and all Americans. And we're going to do that by actually tricking Excel a little bit. What we need here is a one sample t-test so that we can find the average for our one sample of Canadians and compare it to a known average, so that what we already know to be the average among all Americans. We don't have a sample of Americans. We know this to be true from, for example, earlier studies or some other source of information. But there is no procedure in Microsoft Excel for conducting a one sample t-test. The only thing that's readily available in Excel is a 2-sample t-test, which you'll learn to use a little bit later when you genuinely have 2 samples. But we're going to use it here, and what we're going to do is, instead of having a random sample of Americans, we're just going to put a 28 in there for each American, in order to get Excel to compare the average of these numbers to the average of these numbers. Not surprisingly, when you average all these 28s, you're going to come up with 28. That's right. All right, so that's what we're up to. Let's see how to do it. You need to begin by clicking the Data tab up here. And then also over here on the far right, finding the Data Analysis button. Let me give you a quick look at what that looks like right there. If you don't see that, that means you still need to install the Data Analysis Tool Pack in your version of Microsoft Excel. There's a video elsewhere here on the website that shows you how to do that. You have to do it only once per machine, but you do need to do it first before you can do what we're about to look at next. All right, so assuming you have that, go ahead and click on it and scroll down through this list of functions until you find this one, the t-test 2-sample assuming unequal variances. Here's a close-up look at that. Oops. The t-test 2-sample assuming unequal variances. Okay, that's the one you want. So highlight that and click OK. And you get this little dialog box that you simply need to fill out. We have the first thing we need is the variable 1 range. This is the range for the hours spent watching television by the Canadians. I'm going to highlight all of this and just put the cell range in that box. Now, to highlight stuff in Microsoft Excel, you need to find the cell where you want to start. I'm going to start here with the column heading, and then I'm going to click on the left mouse button and hold it while I drag the mouse down to highlight all of the data that I want to include in the analysis. When I get to the bottom, just let up on the mouse button and notice how Excel has filled in the cell values right there. So just click the red X to continue and do the same thing for the variable 2 range. This time, notice I'm clicking on this little icon next to the box. This time highlighting the values for all Americans, all the 28s. Now click the red X again. So now we have these 2 boxes filled out. Now the hypothesized mean difference here needs to be 0, okay? Because what we're testing here is we're testing the assumption that the average for Canadians is no different than the average for Americans. That's where the 0 comes from. All right, so 0 goes in there. There's a labels box here that needs to be checked, because remember, when we highlighted these values here, we included with each one the column heading at the top. That'll make the output a little bit easier to read, but we need to tell Excel that the first cells in those ranges are labels, not numbers. All right. Alpha can stay at 0.05, which is the default. And the last thing is, by default, Excel wants to put the output, the statistics that Excel is about to compute, wants to put it in a new worksheet that you would have to get to by clicking on one of these tabs down here. I prefer to have the output right next to, or maybe underneath, the data that I'm going to be dealing with. So to do that, I'm going to choose the radio button next to output range here. Okay. And then again, click on this little spreadsheet icon. I'm not sure you got a close look at that. That little spreadsheet icon next to the box. And just tell Excel where I want the output to go. I think since I have my screen enlarged here for YouTube purposes, I'm going to put the output right underneath the data, right here in cell A18. Okay, so I just clicked on that cell. Now I'm going to click on the red X here, and we're all set to go. So let's click OK. Alrighty. Now here are the results of the calculations that Excel's done. But notice how everything's kind of squished up. Particularly, I had cell A kind of small here because all I had in there were those ID numbers. What we need to do is expand these cells so we can see everything that's in there. The easy way to do that is to come to the top of the column. I'm going to start with column A here, and I'm going to press my left mouse button and hold it while I drag across columns B and C. So I have columns A, B, and C all highlighted. I've now lit up on the mouse button. And I'm going to float my cursor on the border between any of those two columns. I'm going to just pick A and B here until it changes from a little down pointing arrow into kind of a plus looking thing. And then when it does that, I can just double click, and those columns will expand to however wide they need to be in order to show me everything that's in them. All right. So here's the Ttest output now, right underneath the ID and other data. And there are about three numbers here that I'm really interested in. First of all, here's the average number of hours that Canadians spent watching television. That's the average of these values right here. Okay, and it is 14.5 and some change, about 14 and a half hours on average that our 15 Canadians spent watching television last week. And of course, the average for Americans is 28. That's simply the average of all these 28s here. So obviously there's a difference there. Canadians on average spend less time watching television per week than do Americans, at least in our sample. Now the question here is the difference between 14.5 and 28 large enough to suggest that there's a similar difference in between all Canadians and all Americans? To find the answer to that, you need to look right down here in the P2 tail cell right here under Canadians. And what you see there is a very small number, 0.000521 and some more numbers. But it's a whole lot less than 0.05. Now what that means is that, remember we were testing the idea that the average among this random sample of Canadians was no different from the average among Americans. Well, we got a difference, okay? As we see here, the difference between 14.5 hours and 28 hours. But how likely is it that if there were no difference at all between Canadians and Americans on television habits, how likely is it that a random sample of Canadians would end up being this far below the average for Americans? Well, it turns out it's not very likely. That's what that number means. There's about a 0.0005% chance of getting a sample difference this large between Canadians and Americans if there in fact were no difference in the populations those samples came from. So because that number is so small, because it would be so unusual to get a difference that large, what it means is the next likeliest conclusion is the one that's probably true, that there really is a difference between how much television Canadians watch in a week and how much television Americans watch in a week. All right, so in the next video we'll learn how to build a confidence interval around this average to get a better estimate of about how much television Canadians watch per week. But for now, that's how to run a one-sample t-test in Microsoft Excel.